Okay. So we'll be starting a altogether new kind of a subject, which most of you have not studied so far within the curriculum. Here we'll be dealing with the internal building blocks of a computing hardware. That means those kind of hardware logic which you understood in your digital logic classes, or the architecture and organization of the computing system which you have learned in your computer organization architecture classes, will have a prerequisite need, but altogether we will be breaking those logic building blocks and further moving inside the system. So ultimately, computer is an electrical machine. It works on the basis of receiving electrical signals according to what is being provisioned, and how computer or the basic building block reacts to those signals. What are the switching parameters? How it is at all being working throughout. These things will be our matter of study. So, regarding the academic knowledge is concerned, the advancement of computer hardware is only possible if we have a detailed knowledge in this domain of VLSI. And as because any kind of software development ultimately depends on the hardware platform on which it will be operatable, there are many Fortune 500 companies in the world which deals with computing hardware, which requires employment of engineering graduates who are conversant in certain fields of hardware design. So there are several companies, typically Intel, one of the most pronounced ones, as well as Motorola, National Semiconductors, Texas Instruments, which takes engineering graduates both in the field of electrical and computer science of engineering, with prerequisite knowledge of hardware design, hands-on knowledge in hardware designing languages or description languages, which are HDL. So you haven't gone through these things in the last 3 years of engineering curriculum. So we have two kinds of these very elementary subjects being incorporated in this new syllabus prescribed by AICTE. In the 7th semester, it is VLSI system design, and in the 8th semester, low power circuit. So apparently, it may be posing a certain degree of complexity on your academic load. But frankly speaking, those who will be attending the lecture regularly and be attentive in the class, by the end of the semester, will find the knowledge imparted in a very easy and lucid manner. And understanding the subject will not at all be a tough thing. And for the last 28 semesters, for the last 14 years, my experience of teaching this subject is, at the end of the day, this is a very scoring subject, even more scoring than some of your theoretical computer science subjects. Because there will be lots of design problems, there will be few analytical questions, and in those design problems, scoring 100% is a very easy test if you understand how the design text is. And for the most of the part of our semester lectures, we will concentrate on designing different transistor level circuits, sound stuff, but it will be very easy to do once we have our thorough knowledge in the introductory classes. We try to understand every nicks and bits of the lecture iteration which I mentioned within the time period of the lecture. So even though this is online, this lecture or the paper taken will be in a very interactive manner, and there will be lots of screen work, which I may name it as, because we will not be using any board, so no board work. But there will be lots of screen work. I will be presenting the screen, and there will be writing over there. You can write down as how you have done in most of my offline lecture classes in the college. Also, I will be providing you the PDF files of the lectures which I will be taking, because each and every screen work can be saved as PDF format file, and I will be providing those things after maybe 4 or 5 lectures or such kind of thing, every 4 and 5 lectures. Not after every lecture, but every 4 and 5 lectures, as and when we cover a broad topic and complete those things. Maybe I will be setting that up and be communicating those things to you here. But still, writing down lecture at the time of lecture or understanding it very clearly is a prerequisite for understanding it. Because if you do that, then you will be attentive and you will be concentrating on what I say. Otherwise, I do have experience in the last previous 3 semesters of online lectures that many of your maybe seniors, juniors, or your batchmates just move into the lecture classes in a virtual form and then move out physically. So this will not help in clearing the subject. So this is not such kind of a subject that you study just 2 or 3 days before the examination, because my pattern of lecture doesn't allow that. Every class can be understood if you understand the previous class. So most of the classes are interrelated. Most of the classes. Only when I take up a very new topic, then only you can feel that okay, that doesn't require the just previous classes attendance. So is it clear to all of you what I said just now? Yes,
sir. Yes, sir.
Okay, thank you. And you should also narrate these things to those of your friends who are unable to be present in today's class due to some assessment related activities and so on. And also what I teach in today's lecture should propagate from you to them. So, academics is always a level playing field. The more you disseminate, the more your knowledge increases. So, be selfless and just share the academic knowledge with all of you. It will increase. So let me share the screen first and start the lecture. So is the screen visible? A blank Microsoft Word page has been opened. Is it visible to you?
Yes, sir.
Okay. Now the screen is visible. Yes, is it visible?
Yes, sir.
So the name of the subject is VLSI system design. What is the full form of VLSI? Anyone? Okay. Very large scale integration. So this phase is quite incomplete. So very large scale integration of what? Yes. So very large scale integration of electrical or electronic circuits. So very large scale integration of electrical or electronic circuits. So circuits means it comprises of two kinds of components: active components and passive components. So what are the examples of active components? Examples of active components are diodes, transistors, amplifiers, oscillators, etc. So how can you distinguish? And passive components are resistors, capacitors, inductors. So what are the differences between active and passive components? That are active components take a power supply to get activated. In addition to in addition to its input signal. Right. Now, this power supply in some other terms can also be called as biasing power supply. So, this power supply is nothing but the biasing power supply. The active components requires the power supply to get activated, whereas resistors, capacitors, inductors doesn't require a separate power supply to get activated. Now, both these components require some input signal. This is in addition to the power supply for the active component, whereas the passive components do not need a power supply. Passive components do not need a power supply. So this is the basic difference between active components and passive components. So a combination of active and passive components ultimately creates a circuit. Now, a very important term we can have integrated circuit. So what are integrated circuits? We have different concepts of electronic circuits. If you move into the electronic devices which you have in your home, there are different kinds of electronic circuits. For example, the most common, if you just open up a remote, be it a television remote or the AC remote device, you will find different kinds of boards, small size boards, some colored green, some maybe brown, and so on in color. And there will be plenty of components, very uh, small size components embedded on them. So these boards can be classified more or less into breadboards, and PCB or printed circuit boards. The components which are embedded within these breadboards or printed circuit boards are visible in our day-to-day life. So you can visualize them as individual components. They are within the visible range. And if any of these components gets faulty, you need to pick up that component and try to replace them. But replacement is not at all easy. So right from the scratch, you need to again remanufacture the circuit. So this is how these boards work. It takes into its fold different kinds of electronic components, and based on the electrical signal you provide into that board, it gives a certain output electrical signal, and that is fed within a motor or a generator kind of a device, which ultimately makes your device work. Now, these are nothing but discrete electronic circuits. So, discrete electronic circuits do have components which are connected to one another by virtue of electrical connectivity. There are metallic interconnections, and they can be placed within such kind of platforms which are termed as boards, and a circuit is made. That kind of circuits do have plenty of applications where they are used in our day-to-day life. But they have certain amounts of disadvantage. To get rid of those disadvantages, we will come across these disadvantages one after another. But to get rid of this disadvantage, advancement of these board level circuits is prescribed first in 1960s in USA, mostly for defense uses, but later on commercialized. So what are these? They are termed as integrated circuits. So what are integrated circuits? The or ICs in general, miniaturized active and passive electronic components are integrated within a single piece of semiconductor. So mainly these boards, printed circuit boards or breadboards are such kind of boards which are made of insulating material. But here for integrated circuits, the platform is not an insulating material, rather a semiconductor. And what do we mean by a single piece of semiconductor? A very small geometrical size of semiconductor, be it silicon or germanium. Mostly nowadays silicon is used. That also will come across why silicon is used. But it will be a very small geometrical piece of semiconductor on which different active and passive electronic components which are miniaturized. Miniaturized means the geometrical parameters of these components will be in micrometer ranges at least. Nowadays, it has been further reduced to nanometer ranges. So, what will be the cross-sectional size of this semiconductor which holds thousands of active and passive electronic components? Maybe the cross-section of our one of the single hair, human hair. That may be the size of this semiconductor platform. You can easily assume that the radius or the diameter of a human hair will be in few micrometers, if not less. So that is visible. Now, if it moves to a nanometer range, it becomes invisible by the human eye. But that is the size of silicon crystal, or rather a single piece of semiconductor on which these active and passive electronic components can be integrated, and formation of an integrated circuit is done. So if you have this size of IC, if you have an integrated circuit of this size, you can assume that if within these there are hundreds of active and passive electronic components, or maybe thousands. Nowadays we have millions. So what will be the sizes of each of these transistors or diodes which are being placed within it, or resistors or capacitors. So integrated circuit is a miniaturized and compact form of electronic circuitry packaged in such a way that if you do not break open this, you cannot see any of the components. You can only see this packaging along with this output and input metallic wires, which are named as pins. So these are nothing but pins made of metal. So what is the advantage of using an integrated circuit over the previously mentioned discrete electronic circuit? There are plenty of advantages. So advantage of ICs over conventional circuits. There are plenty of advantages of using an integrated circuit over conventional circuit. So the first one is integrated circuits can be batch fabricated. Now we have used these two terms, batch and fabricated. What is the meaning of batch? Means thousands of integrated circuits of the same type is termed as batch. And fabrication is the manufacturing process of any semiconductor device. Fabrication or fabricate means the manufacturing process of any semiconductor device. So ICs can be batch fabricated, can be manufactured or more pronouncedly thousands of ICs can be manufactured at a single process. So if this can be done, then of course the costing of manufacturing of IC will be very less. The costing of manufacturing of a single IC is very less. Mind it, of a single IC, because thousands are batch fabricated. But if you consider the overall costing of manufacturing process, it is very high. But as because thousands of ICs can be manufactured at the same instant, per unit manufacturing cost becomes low. Per unit manufacturing cost becomes less. Is it clear, students? Is it clear?
Yes, sir.
Okay. The second advantage of integrated circuit, ICs are very small in size and weight. ICs are very small in size and weight. So if integrated circuits are very small in size and weight, they can be used in specific critical applications. For example, cockpit of an aircraft, then within spacecraft, missiles, so on. So in critical applications where weight and size are slightest difference in weight and size can speak of the success or failure of the project, integrated circuits are mostly used. Now, if you consider today's world, then every FMCG product use ICs in today's world. This what I am mentioning is in 1960s and 70s, just after the invention of integrated circuits, they were used in mostly weight and size critical applications. But now every FMCG product use IC. What do you mean by FMCG? Anyone? Anyone? What is meant by FMCG?
Fast moving consumer goods.
Exactly. First, movable consumer goods. Example?
So like groceries or shampoo, something like that,
No.
TV, electronic devices other
Yes.
than mobiles.
TV, washing machine, mixer grinder, refrigerator. So any so everywhere in today's world we will be finding integrated circuits due to the advantage of size and weight. The third advantage of IC again as because uh, their maintenance is quite easy. So fault recovery. If ICs becomes faulty, then you can change the integrated circuit in a very easy manner rather than detecting at which component there is a fault and then desoldering that component, reattach another component, again test it in a continuity test method and so on. So this huge burden of electrical testing is done away with, and you can very well replace. So replacement of ICs are easy. The fourth advantage, miniaturization and cost reduction of IC give huge huge is not the appropriate term, give advantage on complex applications. So you can easily assume the sizes of today's computing devices. In 1960s or 1970s, computers were mainly analog devices with sizes of a big room or laboratory. The whole lab or the big uh, practical room took the size of a computer. Computers comprised of different large size boxes and panels and everything, pillars connected with complex wires and all these things. So a single computer took the size of a room or a laboratory. So such kind of computers were available in Indian Statistical Institute, Kolkata, in those days. One of the few computers in India, analog devices. After that, due to the advance of or the advancements of integrated circuits, you can easily assume what is today's sizes of computers or computing devices. Even your mobile is now a computing device. There are several notepads or palm tops and everything available. Forget about laptops and desktops. They are now considered as large. So this can be only possible due to the advancement of integrated circuits. Because integrated circuits came into existence and your processor just took the shape of a big size eraser. The processor of your computer, which have within it millions of transistors, maybe 10 to 20,000 of transistors, or even more than that, took the size of a large size eraser. So, then, what is the fifth advantage? Signal flow rate. The rate in which or the speed in which electrical signals flow through your uh, integrated circuit is much higher than that of the discrete electronic circuit because due to small sized components. So what will be the signal flow rate? So for any ohmic conductor, the signal flow rate is nothing but the current and it depends on how much resistivity a ohmic conductor performs. So if this is a ohmic conductor AD, so the signal flow rate depends on dA minus dB divided by the resistance value. So what is the resistance value? How these resistance depend? R is proportional to the length of the conductor. So if you can reduce this length value, if you can reduce this, so miniaturized components, if you reduce the size of the components, this L value reduces. So if this L value reduces, this resistivity reduces. If this reduces, I increases. Is it clear? So the sixth advantage, high frequency application. So the integrated circuit perform better for high frequency applications than conventional discrete circuit. Conventional discrete circuit. This has been observed. So there are plenty of advantages why we use an integrated circuit. There are plenty of advantages. So if you want to classify integrated circuits can be so ICs can be classified based on two criteria. First one is based on manufacturability. How they are manufactured, manufacturing based on the manufacturing, and second based on its operation. So based on how they are manufactured, it can be classified into two categories. One, monolithic IC. Second one, hybrid IC. So what are monolithic IC? Components integrated on a single piece of semiconductor. So components integrated on a single piece of semiconductor. Basically, the definition of integrated circuit which we had given previously, that is nothing but monolithic IC. What are hybrid IC? Here, the components are on a ceramic platform. Ceramic material means the insulating material. So they on a ceramic platform. But then also this is not a discrete IC due to components can be ICs itself. So multiple monolithic ICs along with other different components are embedded or integrated on a ceramic platform to create a hybrid IC. So what is the basic difference between monolithic IC and hybrid IC? Multiple monolithic ICs along with other components form a hybrid IC. So it is termed as hybrid because monolithic ICs along with discrete electronic components embedded on a ceramic platform can create such kind of specialized IC called hybrid IC. Is it clear? Then based on operation of integrated circuit, ICs can be again classified into two categories. First one, linear IC, and second one is digital IC. So linear IC and digital IC. Now about digital IC, we do not have to speak much. Digital ICs means we can manufacture digital integrated circuits which considers only digital signals, input signals, and gives digital output signals. So mainly the most of the ICs used in the computers or computing devices are nothing but digital ICs. And in most of the part of our curriculum, we will try to design or try to move into different characteristics and aspects of these digital ICs, because these are the ICs of today. But what are linear ICs? Even linear ICs have huge range of applications. So we need to understand very briefly what are linear ICs. So before understanding what are linear ICs, we need to understand the property of linearity. Anyone knows what is the property of linearity? What do we mean by linearity or the property of linearity? So linear ICs are analog ICs. So these take continuous signals and it also outputs signals which are continuous. That means in time domain. So if you represent continuous signals, you can represent the continuous signals using this function x of t, where t can attain any value. So if xt is the input signal and the linearity principle gives output yt, or any system gives the output yt, then for similar kind of signal x1t, output can be y1t, as well as a signal input signal x2t, the output can be y2t. So what is the principle of linearity? If the input signal is a combination of two other input signals, if the input signal is a combination of two other input signals, that means x1t plus x2t. If this is the input signal, then we can get an output signal also as the combination of output signals for these two individual input signals. That means when the input signal is a form of combination of individual input signal x1t and x2t, then for a linear system, it gives an output which is also the combination of individual output signals for these individual input signals. Now, this combination can be weighted in nature. For example, if xct is the input which is a into x1t plus b into x2t, where both a and b are arbitrary constants. Arbitrary constant values. So if xct is the input signal, which is a combination of two other input signals in a weighted form, these a and b are weights, which are arbitrary constant values, then we can get an output called y3 of t, such that it will be T into x3 of t. So what is T into x3 of t? Sorry, this is an example of a linear system where the functionality comprises of the time into multiplied by another input signal. So this is a particular example which we are studying, that we are trying to understand whether this is a linear system or not. So it will be linear system if Y3T will be attaining the same weighted form of individual Y1T and Y2T. So if Y3T is T into X3T, it simplifies into T into X3T is A into X1T plus B into X2T. So it is A into X1T plus B into X2T. So what it becomes? A into T into X1T plus B into T into X2T. Now what was our functionality? Here Y of t equals to T into X of t. This was our function which we took, and we are cross checking that whether this is a linear function or not. So here xt comprises of this, because we are replacing xt with x3t and it becomes a into x1t. It was a into x1t plus b into x2t. So this is nothing but a into y1 of t plus b into y2 of t. Why? Because y1 of t is t into x1 of t, as because one equals to t into x1 of t. So y1 of t is nothing but t into x1 of t, and y2 of t is t into x2 of t. So we are replacing t into x2 of t as y2 of t and t into x1 of t as y1 of t. So y3t now becomes a into x1 of t plus b into x2 of t. So if the input is a weighted sum of previous two inputs or any other two inputs, then the output will also be the weighted sum of those outputs for those respective inputs which we have considered. Is it clear, or I will explain further?
Sir, please explain once again.
Okay. So the principle of linearity ultimately speaks of such kind of a system where if one of the inputs is the weighted sum of previous two inputs, then the output also will be the weighted sum of those previous outputs with respect to those previous inputs. This is the statement of what is linearity. To explain that, we have considered a system such as yt equals to t into xt. This is a system function. Yt is the output of a continuous system. It is t into x of t, where xt is the input signal and yt is the output signal. Now, if we consider this as the system function, we can consider y1 of t equals to t into x1 of t, where x1 of t is the input and corresponding output is y1 of t. Similarly, y2 of t equals to t into x2 of t, where x2 of t is the input and the corresponding output is y2 of t. So these two are non-weighted inputs being provided, and we are getting a corresponding output. Now, if we use a weight function such as a and b, we incorporated within the signal, and we just deduce a new kind of a signal. We deduce a new kind of a signal called Y3 of t. How? As a weighted sum of individual inputs, A into x1 of t plus B into x2 of t, where A and B are arbitrary constant. Then, based on Y3 of t input, we will be getting another output called, based on X3 of t input, we will be getting another output called Y3 of t. And what will be this output function? Based on Yt equals to t into xt. So Y3 of t will be t into x3 of t. Is it clear up to this?
Yes, sir.
Now we will try to simplify this and make it in a form of weighted sum of individual outputs for these individual inputs. What are those individual outputs? Y1 of t and Y2 of t, because within x3 of t we have individual inputs x1 of t and x2 of t, and corresponding x1 of t and x2 of t we have y1 of t and y2 of t. So we will try to analyze that y3 of t will also be a weighted sum of y1 of t and y2 of t. So we minimize this t into x3 of t. We replace x3 of t as a into x1 of t plus b into x2 of t. So it becomes a into t into x1 of t plus b into t into x2 of t. So a into t into x1 of t is nothing but y1 of t, and t into x2 of t is nothing but y2 of t. So ultimately it becomes a into y1 of t plus b into y2 of t. So if the input is the weighted sum of previous two inputs, the output, corresponding output will also be the weighted sum of individual outputs for those corresponding inputs. Is it clear?
Yes, sir.
If we can prove this, we have proved this based on this functionality yt equals to t into xt. So if we can deduce this, then we can say that this function is a linear function, and this is the property which if this property the signal follows, then the signal is a linear signal, or it is the property of linearity. You will not find every functional value or the functional property as linear property. There will be such kind of functions where this proving will not be done. You cannot prove this. If you cannot prove this in a segregated manner, that function will be a non-linear function. So there is altogether 100 marks undergraduate paper of signals and systems which deals with various kinds of electrical signals, where this property of linearity and every other, there are property of time invariance, there are property of causality. So there are several signal properties of electrical signal which can be considered. So that is altogether 100 marks paper. I am not going into details of those individual properties, but for the linear ICs or how this linear IC is characterized, we should understand what is the property of linearity. So linear ICs maintain or it undergoes the linearity property. So it maintains or undergoes the linearity property. Now, what is the linearity property? That I have explained using a very simple example of a continuous function. So whenever you are giving within first bracket this small t symbolic value, this is not at all a discrete signal. This is a continuous signal. Continuous signal means it is continuous in time and continuous in value. So the main difference between a discrete signal and a continuous signal means the continuous signal is continuous in time and continuous in value, whereas a discrete signal considers discrete timing instance and takes quantized value. So a discrete time signal and discrete value signal is nothing but a digital signal. So what is a digital signal? Digital signal is nothing but an analog signal with certain degree of approximation. So analog signal with a certain degree of approximation. Why approximation? Say this is an analog sinusoidal signal where this horizontal axis is the time axis and vertical axis is the amplitude axis. Amplitude is usually denoted by voltage and obviously the time is denoted by second. So this is a sinusoidal signal. This is a continuous time signal. You can symbolize this sinusoidal signal as x because this is a continuous time signal as well as a continuous value signal. You can have different values, different amplitudes in different timing instants. But if you quantize this signal and take only specific values after specific time intervals, this becomes a discrete time and discrete value signal. So if you just quantize them, so it becomes the signal becomes like this. So whenever you use a discrete time and discrete value signal, it is denoted by x of n, small n or capital N, where n gives these instant timing instant. And when this discrete time, discrete value signal is further approximated to only two specific values, either say 0 volt at this horizontal level and after a certain degree plus 5 volt. If you take only these two values, then it becomes the binary signal with representation of logic 1 and logic 0. Is it clear? So linear ICs deals with continuous time signals and continuous value signals, and they have certain properties. One of the properties, very important property, is the property of linearity, which has been tried to explain you in today's class based on a system function called xt equals to t, yt equals to t of x. If this is an example linear system, then how you can prove that okay, this system is linear? This system can only be linear if the input is a weighted sum of previous two inputs or any two inputs, and the output will also be the weighted sum of those individual inputs, those individual outputs corresponding to those individual inputs. So we have proved that, and so it is proved that this system follows the principle of linearity, or this is a linear system. So those integrated circuits which follows this principle of linearity undergoes the linearity properties, nothing but the linear IC. And the digital ICs are nothing but discrete time signals and discrete value signals, which deals with this are nothing but digital ICs. And in most of our applications, we deal with the binary signal where these discrete values are only two values, either 0 volt plus 5 volt or any other thing. So in most digital ICs, we use these two discrete values, plus 5 volt and 0 volt, and corresponding to logic 1 and logic 0. Is it clear up to this? Only one student is present.
Yes, sir. It's clear.
Yes, sir. Yes, sir.
Okay. So let this lecture stop up to this. We'll move into further in our next lecture class. And there is a very important law or hypothesis named Moore's law, based on the co-founder of Intel Corporation, Gordon Moore, who prescribed that. And it was a very long durated law, which was valid just before a couple of years even. And there are exceptions of Moore's law nowadays. We'll learn each and every of these, and then we'll move to semiconductor physics for a couple of lectures. And believe me, those things will be quite convincingly clear to all of you. But ultimately, we have to stepwise move into the complexity of the syllabus or the subject, and that will be done easily. But maybe the first lecture or the second lecture will not give you an whole idea about the subject as a whole. Slowly moving on, you will be getting the idea. So, as we all know, Rome was not built in a day. It was built in steps and decades and years. Thank you, everyone.
Thank you.
Thank you. So tomorrow probably we will be taking another class. I will be intimating you through the CR.